Welcome to the updated video for assembling your inverted Thrifty Swerve. This video includes the latest changes up to 2026. For tools, you're going to want some soft pliers, a set of T-handle Allen wrenches or some L Allen wrenches. Do not use a drill. If you have that, go put it away. Double check against the Thrifty Swerve bomb. We have a link for that in the description. You're also going to need some Loctite, so make sure you have either the solid stick or the liquid 243 and some green Loctite. 638 works nicely. And just make sure you have all the parts. So another thing I recommend having pulled up when you're assembling your Thrifty Swerves is the Thrifty Swerve on-shape document. There's a nice configurator that allows you to select your drive motor, your azimuth motor, the different gear ratio types you're using. It also allows you to select which wheel you are using, and depending on which wheel you're using, there are some different upgrade hardware kits that we sell. We've also designed a side, top, and bevel gear cover that are all 3D printable. Those will adjust depending on which drive motors you're using as well. So just a really handy thing to have open while you're assembling these. You can also click on any of the parts and it'll show you the bolt or bearing name. So yeah, I just recommend keeping it open. It's a nice reference to have. First, we're going to get that top plate, base plate, and the lower support plate. We're going to unwrap all of those. You also want a few bins to put parts in. For example, the bolts kit, we just dump all of those so we don't lose those. Open up the X contact bearing, get it out of the packaging, and you'll want to insert that into the base plate. Now we need to secure the X contact bearing in the main plate. So you have 6 1032 button head bolts. Again, you'll want to use Loctite on a lot of these different bolted connections. We're not going to show that on every step of the video, but it would be really smart to apply Loctite so these things don't come loose during your season. And we have another bin here for our small bearings. It's smart to just put those into a bin together so we don't lose any of them. You'll want the upgraded shaft and bearings bag from the shaft and spacers kit. Now grab the 6801 bearing that comes in the bearings kit and press that into the azimuth gear. We'll take the bevel shaft out and slide that into the 6801 bearing. Now on this next step, Thrifty Swerve provides you with 2 shifted profile gears, a 16-tooth gear and an 18-tooth gear. Depending on which gear ratio you're running, you need to choose one of these 2 options and just make sure all of your modules are the same. We'll need the snap ring clip that's included in the bag. This part is the bevel shim. Let's set that aside for a second, but we will need it soon. And again, make sure you are using either the 16-tooth or the 18-tooth gear consistently across all your modules. We're going to slip that snap ring clip on, and now's where you take your pair of pliers and just press it onto the slot in the shaft. Now we'll assemble the azimuth gear into the base plate. It'll just snap into the X contact bearing. And then let's grab the small bevel gear from the bevel gear bag and slip it onto the small bevel gear shaft. Next, we'll want that shim we had talked about earlier. You're going to take that out of the bag and place it on top of the small bevel gear. And then the 2 bearings that are in that bag go on next. You'll take the larger of the 2 and slip that on. And then take the smaller bearing and slip that onto the shaft. Next we'll take the fork that has the cutouts for the bearing stack, and it'll just cap off the entire bevel gear shaft. Grab 2 of your 1 1/4 inch long 1032 socket head bolts and just start to tighten those in by hand. Once you get both started in there, you can take your Allen wrench and snug them up. Again, you'll want to use Loctite on these to make sure they don't back out as the season goes on. Now we'll take 2 of the 6802 bearings that came in the kit, and they should just 2-finger press into the double gear. Now's a good time to get our absolute encoder magnet placed into our center column shaft. In this example, we have the Thrifty analog absolute encoder. It comes with a magnet. We're using Loctite 638 to make sure it stays in there. If you don't have that on hand, you could use super glue or hot glue, but you really want to use an adhesive to make sure that these magnets don't rotate or come out during the season. If they start rotating on you, then your readings will not be correct and you'll be confused on why your swerve drive isn't operating properly. Take the large bevel gear and it should slip right onto your 4-inch billet wheel. There are 6 832 bolts in the kit, and you're going to use these to attach the large bevel gear to the billet wheel. Again, you'll want to use Loctite on these to make sure they don't come loose during the season. Now it's time to put some of the gearing on top of the main swerve plate. We need to take our 6700 bearings and slip those into the base plate. And then take the 3/8 hex shafts and press those into the 6700 bearings. Now you have a choice to make. The azimuth gear can go on either one of these, and the drive gears can go on either one of these. So your team needs to choose whether you're going to have the azimuth be the right side shaft or the left side shaft. In this case, we picked the right side, but it's totally up to your team. On the opposite shaft, you're going to put that longest hex spacer on there. And then you'll take the second longest spacer and place it on top of the 12-tooth gear that's interfacing with the azimuth gear. Then grab one of the big 50-tooth spur gears and place that on top of the spacer. And then you'll take the smallest spacer that's left and place that on top of the spur gear. Grab the other 50-tooth spur gear and place that on the opposite shaft. I found that it helps a lot to have something to rest the module on, so we grabbed our bolts bin, and it just kind of serves as something to help keep it propped up and vertical with all these parts on there. Now you'll grab the 6800 bearings, there are 2 of them, and place those on top of the 3/8 hex shafts. And we have our last 6802 bearing. That goes on top of the center column shaft. It's a little bit difficult because of the magnet, but you should be able to get it on there pretty easily. And then you're going to take your top plate with all those bearings on it. It makes it pretty easy to align and get it to snap nicely onto the 3 shafts that are sticking out. Now we'll use our 4 1 3/4 inch long spacers and grab 4 of our 2 1/4 inch long 1032 socket head bolts. You should be able to slip the spacers in there and start to hand tighten these bolts one at a time. You'll want to get all 4 of them in there, and again, you'll want to use Loctite on this because you don't want those coming loose on you during the season. Once you get all 4 of those started, use your hex driver and start to tighten them up one at a time. Once you get them snugged up, just make sure everything is rotating and spinning smoothly. There should be no binding. Everything should rotate smoothly still at this point. Now we're going to start to attach the tread to the billet wheel. To make this step a little easier, I always put the tread on our 3D printer bed, crank it up to 50°C, and let it warm the tread up for a little bit. This makes it more pliable and easier to attach. So we're going to line up the end of the tread with 2 of the holes. You'll start where there are the 4 holes on the wheel, and you'll take your 1/2 inch long 1032 button heads, and with this it's very much a feel thing. You want to feel the thread of the bolt catching. I highly recommend using either a T handle Allen wrench or an L, or maybe a combination of both here. It's a little bit tricky, especially if you've never done it before, so I just really recommend you take your time on this one. And if it feels like it's starting to cross thread, or if the bolt essentially just isn't going in, back out, really look at it, and try to make sure it's going in straight on with the hole. It also helps to wear gloves. I'm not doing it here because I've done this so many times, but you may want to wear a pair of gloves, as the nubs on the tread are very stiff. This is by design. This is a very hard durometer tread that will last you several competitions, several practice sessions. Once you get this on, you shouldn't have to switch it very often. But the trade-off for that is it is a little difficult to install. So take your time on this. I'm using an Allen here, but you'll see later I switched to a T handle because honestly the T handle is probably the right tool to use. So if you have one of those, grab that and really just try to get the bolts going in straight. And you can see here on my hands, like it's leaving marks from the nubs. Again, we'll probably wear a pair of gloves. And the last ones are for sure the hardest of the 2. That's why I got the T handle out. It kind of helps if you can pry that 1032 until it's perfectly straight and then start to twist it. Now we need our 3/8 by 7/8 bearings. Those should just slip right into each side of the wheel. And for this next part, I take the opposite side of the fork and the shoulder bolt. I slide the shoulder bolt through the fork and then through the wheel bearing stack. Make sure you get the fork on the right side. It should go on the opposite side that the large bevel gear is attached. One of the tricks I use to make this step easier is to get the shoulder bolt started on the opposite side of the fork. Now it doesn't mean tighten it all the way up, but I'll start to tighten that by hand, and once that shoulder bolt engages, then I take my other 2 1032 bolts, slip those into the fork, and I'll start to tighten those up as well. Getting all 3 of these kind of loosely started just helps make sure things are aligned. You can spin the wheel as you're doing this too to make sure that the bevel gear is properly engaging and doesn't feel too rough. And once you get it all snugged up here, give the wheel a spin, make sure everything is rotating smoothly. We have seen the tread sometimes just barely catches on that as you're spinning it. Once you start running it, that's going to wear right in, so don't worry about that. And now it's time to start attaching some motors. In this example, I'm using the Rev Robotics Neo motors, so I do need my 2mm machine keys. If you're using a Kraken, you don't have a machine key because it's a spline motor. And I highly recommend just pulling up the Onshape model. You can turn on the configuration that you're using. It'll show you the spacer stack combinations and the order they should go in. In this case, it's a small spacer plus the machine key on top of that. And then we're going to pick, in this case, we're doing the azimuth. So I'm putting my 12-tooth gear on there. The azimuth always uses the 12-tooth gear, and the larger spacer goes on top of it. So Thrifty Swerve has billet motor spacers that work for either motor type. To get those on, I usually put the 3 1032 bolts into the top plate first, get them aligned through the billet motor spacer, and then get them aligned on the motor itself. You can start to tighten those up. Again, you want to get all 3 of the bolts engaged before you really snug everything up super tight. There is an 8mm ID bearing that goes into the top plate for either motor type as well, so you can install those. And then we have a spacer that offsets the excess amount of the shaft that sticks out, and you can put the 1032 bolt in there to secure that as well. So it really helps keep everything nicely aligned with that extra bearing in there. So snug those up, and then just make sure your azimuth is rotating. Obviously it's not going to be as smooth with no motor, but it should still feel fairly smooth. For your drive gears, we give you 3 pinion options. There's a 12-tooth, a 13-tooth, and a 14-tooth gear. This is how you change your gear ratios with Thrifty Swerve. And you just want to make sure, again, that you're using the consistent same gears across all of the modules that you're building. If one module has the wrong gear on it, it's going to go at a different speed than the others. So an important thing to make sure that you're keeping consistent. And on the Neo here, we're going large spacer, then machine key. I'm using the 12-tooth gear here for the drive because I don't want it to go super fast. Smaller spacer on top of that, and again, I'm putting my 3 1032 bolts in through the top plate and getting my billet motor spacer on there. And again, then I snug those 1032 bolts up, but not all the way yet. And then it's time to put the 8mm bearing in there and then snug everything up tight. You want to do that after you get the bearing in there. I'll place my spacer on top and my 3/8 1032 button head bolt and tighten all those up. So that's about it from the motor installation perspective. Now we need to install our encoder on the top plate. Thrifty Swerve works with lots of different encoder types on the market. Typically we ship it with this analog encoder, but since the Robo Rio is going away, we will start shipping it with this 10-pin encoder that plugs directly into the Thrifty Nova. If you're using the CTRE CAN coder, that's perfectly fine as well. Just make sure you're using the correct length of bolt that isn't going to run into the bearing below the top plate. But here I'm connecting it with the ribbon cable that's included with the 10-pin encoder that plugs directly into the Thrifty Nova. So in the Thrifty app, we will see the encoder readings there. And the 10-pin encoder by ThriftyBot also has an LED that shows you if it's aligned or not. So if it's red, it's not aligned. If it's green, it's detecting the magnet. Make sure to check out our other Swerve videos for our end-to-end Swerve drive setup.